Hello, and welcome to another video demonstration of SimWise 4D. This is also one of the tutorials that come with SimWise. You can find it by starting SimWise, clicking on Help Tutorials, and choosing Modal Frequency Response from the list on the left. This demonstration will show how SimWise FEA can be used to perform a frequency response analysis, which is an analysis type introduced with SimWise version 9.9. Frequency response analysis is used to calculate the steady state response due to a sinusoidal load applied to a structure at a single frequency. It is a specialized type of transient response analysis that is extremely efficient to solve. Unlike modal analysis, which only calculates the natural frequencies and the corresponding mode shapes, frequency response analysis calculates the actual deformations and stresses that occur with a particular set of structural loads and restraints. It does this by varying the loads in a sinusoidal manner and calculating the resulting response at each frequency of interest. It allows the frequency ranges that could cause problems with the part to be identified. This is a model of an ultrasonic welding horn, or sonotrode. It is the end part of an ultrasonic stack that transmits sound energy from an ultrasonic transducer into two parts that will be joined together at their connection via the absorption of sound energy. Ultrasonic stacks are tuned to work at certain frequencies, such as 15 kilohertz. In this example, we will look at the frequencies between 10 and 20 kilohertz and determine the maximum stresses encountered by the horn within this frequency range. The first step is to generate the mesh. So we can include this part in the FEA model. We'll use the default mesh size of 15 millimeters. We'll mesh the part, which produces a mesh that looks like this. We won't turn the mesh on since we don't need to see it for the remaining analysis. The next thing we need to do is add some restraints. So we'll restrain these flat faces. And then we'll change the restraints on the flat faces to only produce a restraint that's normal to the face that they're attached. The last thing we need to do is add a load. So we'll add a load to the bottom surface of the horn, and we'll change that load from a total force load to a pressure load, and we'll apply a pressure of 0.1 megapascals, which is equivalent to about 14.5 psi. Now we can go and select the analysis type we're going to do, which is a frequency response analysis. And if we click on the frequency response page, we can specify the frequency range we want to investigate. So we'll look between 10 and 20,000 kilohertz, 20,000 hertz, and we'll ask for 200 different frequencies to be examined within that range. Next thing we do is push the solve button, and SimWise will go and calculate the frequency response of this part. The analysis is complete. The model is shown at the low end of the frequency range at 10 kilohertz. The model is blue because the stress in the model at this frequency is very low. To see where the frequencies of interests are, we can create an FEA meter. The meter plots stress on the y-axis versus frequency on the x-axis. There are two peaks around 15 kilohertz and 17 kilohertz. We can grab the meter slider and move it over to the 15 kilohertz peak. And we can see the frequency at this peak is exactly 15.6 kilohertz, and the stress peaks at about 108 megapascal, which is about 16,000 psi. We can also ask SimWise to show the deform shape, and we can animate that deform shape. to see how the part would vibrate at this frequency. Since the stack is tuned to operate around 15 kilohertz, we can see that we are quite close to that frequency and have a good idea about what kinds of stresses the part will encounter when it operates at that frequency. This concludes the frequency response demonstration of SimWise 4D. Thank you.